Hi friends, welcome to Google Cloud with Yash. Today we are going to learn about Introduction to Google Cloud Platform, Module 2. Google Cloud Platform offers different services. Like for example, in Compute Engine we have Compute Engine, App Engine, Kubernetes Engine, and GPU, Cloud Functions, and some container optimized operating systems. And in AI platforms, we have Cloud Vision API, Speech to Text APIs, and Video Intelligence APIs, and Cloud Auto ML, and Cloud Translation APIs, and so on. And in Big Data, we have BigQuery, Dataflow, Dataproc, Dataprep, and Composer, and Cloud PubSub, and Data Studios. And in Identity and Security, we have IAM, and Resource Managers, and Security Scanner, and Key Management Service, and Cloud Security Command Center, and so on. And in Data Transfer, we have Transfer Appliance. We will talk about this every service in later classes. And in Management Tools, we have the Stripe Driver, Monitoring, Logging, Error Reporting, Trace, Debugger, Cloud API, Console, Shell, Cloud Mobile App, Cloud Billing API, Profile. These are all very important tools we use in the future classes. And in networking, we have the VPC, Virtual Private Cloud, Cloud Load Balancing, Cloud CDN, Cloud External IP, Firewall Rules, Router, Cloud DNS, Network, Routes, VPN, Interconnect, Cloud Armor, and Premium Network Tier and Standard Network Tier. We have Developer Tools SDK, Cloud Source Repositories, and these are all the developer tools available in the GCP, Google Cloud Platform. These are the API platform and ecosystems, API Analytics, Cloud Endpoints, Developer Portal, and API-Sense. And in IoT, we have Cloud IoT Core, and in the storage and databases, we have the Cloud Storage. This is very important. And we have the Cloud SQL and Cloud Spanner, Persistent Disk. We will talk about everything, every service in the later classes. Let's come into the virtual machines. Virtual machines are one kind of services in Google Compute Engine. And in virtual machines, they are called instances. To build an application, we have to choose the region and zones to deploy resources, where data is stored and used. And we have to choose the operating system and development stacks, language, framework, and services. We can create the instance from public or private images. We use Google Cloud Marketplace to quickly deploy pre-configured software packages. Example, we can deploy LAMP or MeanStack. We can create instance group to manage multiple instances together. We can use auto-scaling with instance group to automatically add and remove capacity. And attach and detach the disks as needed. We can use SSH shell to connect directly to the instance. And in computing in virtual machine instances, we have 1 to 96 processors and 6624 GB, and we have disk limits of 65 terabytes persistent disk and 3 TB SSD and 208 RAM. And in pre-configured images, we can build in our own. Coming to the file storage. And in cloud storage are like one set of interfaces. And there are several types like multi-region and regional, nearline, cold line, and in storage services, these are used to store data of your application. It will be consistent, scalable, and large capacity data storage in cloud storage. Standard cloud storage provides maximum availability. And in cloud storage, nearline provides low-cost archival storage and it is ideal for data access in less than once a month. For cloud storage, cold-line providers need lowest cost archive storage, and this is ideal for data access in less than once a quarter. In cloud storage archive, it provides the lowest cost archival storage for backup and disaster recovery. and it is ideal for data you intend to access less than once a year. We can easily understand, for example, for nearline we will use the data less than once a month. For coal line we can access the data less than once a quarter. For archive storage we can access the data less than once a year. And we also have persistent disks and compute engine. They are used as primary storage for our instances. Compute engine also offers both hard disk based persistent disk called SSD, standard persistent disks and SSD. And fully managed file servers and file store. You can use file store instances to store data from applications running on compute engine, virtual machine engine, or Google Kubernetes engine clusters. For high performance object storage, we use multi-regional and regional. As I already discussed, multi-project start with multi-regional storage, which is optimized for geo redundancy and end-user latency. And for regional, we use projects require higher performance local access to computing resources. When you need to support high frequency analytic workloads, we use regional storages. For backup and archival storage, we have nearline and cold line. Nearline is used data access less than once a month, and this is data access less than once a year. These both are backup and archival storages, and these both are high performance object storages. Cloud SQL. Cloud SQL is a fully managed relational database service for MySQL, PostgreSQL, and SQL Server. And this is a traditional SQL server, and it was vertically scalable and it can be managed for data backups. And it is easy to set up replicas, and we have types of SQL, Cloud SQL, MySQL, and PostgreSQL. It will reduce the maintenance cost with fully managed relational databases in the cloud. It will automate database provisioning, storage capacity management, and other time-consuming tasks. Database observability made easy for developers with Cloud SQL insights. We can easily integrate with existing apps and Google Cloud services like ZKE and BigQuery. Cloud Spanner. Cloud Spanner is a structured data, and it was highly available and it was strongly consistent. And it was globally distributed and horizontally scalable, and it is also cost effective at scale. Cloud Spanner is used in so many big MNCs and industries. Cloud File Store. Cloud File Store is a high performance and fully managed file storage. A fully managed network attached storage allows for compute engine and Google Kubernetes instances. Can predictable price for performance, and it will scale to hundreds of terabytes of high performance workloads. It was a managed file storage, and it has two performance types. One is throughput 180 MB per second versus 700 MB per second. And it has the max of IOPS 5000 versus 30,000. It has the maximum capacity of 64 terabytes and NFSCV 3 protocol. And instances group. What is instance groups? Instance groups are a group of virtual machines. They create from instance template and manage or unmanaged instance groups. We can automatically configure to work with load balance. They are managed instance groups. They can do auto scaling. They can also do auto heal, and they can auto scale by policy like CPU utilization and HTTP load balancing utilize a request per second. And they auto scale by policy stack driver monitoring metrics. Microservice and architecture with cloud native application. By choosing the right compute option, if you want to go with a high customizable, then you have to go with Google Compute Engine or Google Kubernetes Engine. If you want to go with highly managed, then we have Google App Engine (GAE) and Google Functions and Firebase. What is Google Kubernetes Engine (GKE)? Google Kubernetes Engine is a managed Kubernetes cluster, and it is a container orchestration system, and it can organize the workloads with these features like monitoring, logging, DNS. DNS is a domain name service, and service discovery and auto scaling. We will talk about Kubernetes Engine in later classes. App Engine. App Engine is a serverless service provided by the Google Cloud Platform. It supports the various programming languages like Python, Java, PHP, Go, and Node.js. With the help of these languages, you can create several applications, and they have some constrained capabilities and incredible rapid scale. Cloud functions are also serverless services provided by the Google Cloud Platform. Google Cloud Functions are the function-based, and they are managed with Node.js CLV, and they are all event-driven. For example, Google Cloud Function is like a function. They will trigger when you want to, if you want to run some specific task after some task, then you can use Cloud Functions. With the use of Cloud Functions, you can trigger these Cloud Functions at any point of time in your application. Then they will trigger in your application. Compute Engine, they are virtual infrastructure, raw compute, granular control, and Kubernetes Engine is a containerized apps data center as PC. For App Engine, it is a platform as a service, persistent preset runtimes, focus on app logic, and Cloud Functions is a event-driven architecture, glue pieces together. And these are some of the things. They are good for existing systems, and we have to think about the services before using the services in Google Cloud Platform. And these are the pros and cons. In Compute Engine, they have very fast network interconnect and any mission shape provisioned under 30 seconds, and SW licensing requirements and so on. And they have cons, slow scaling speed, and they need to handle updates. For Google Kubernetes Engine, the pros are open source, and it is logical level representation, and it is a non-HTTP protocol. And for Kubernetes Engine, the only con is they must use containers, because Google Kubernetes Engine is a containerized platform, containerized service. For App Engine, we have pros code first, HTTP request, and production version management, and we have the constrained runtimes. And in Cloud Functions, we can event via pub or sub, and they are fully managed environment. We have to pay only for what you use, and they use standard Node.js runtime. And the cons are they must interact via events, because Cloud Functions will be triggered only for the events, and they are function level granularity. The con is functional level granularity. For compute options decision tree. For example, if you are a mobile or HTML5 developer, then you have to go with Firebase. Or else, if you are developing an event-driven app, then you have to go with, if yes, then you have to go with Google Cloud Functions, or no, if your application, any of the following, like if the application is using a specific OS or kernel or using GPU, then you have to go with Google Compute Engine. If no, then does your application use or need any of the following, like hybrid or multi-cloud deployment, licensed software, and use of protocols besides HTTPS? And if it was already existing app, then will you If no, then you have to go with Google App Engine. If yes, will your app be in containers? If it was a container, then you have to go with Google Compute Engine. If yes, you have to go with, do you plan to use Kubernetes as your orchestration? Then yes, obviously Google Container Engine. If no, you have to go with Google Compute Engine. Now time to results comparison. In networking services, we have Google Cloud Virtual Network, VPN and Firewall. In Cloud Virtual Network, we can create custom private cloud networks and we can set up custom routes to your other non-Google locations. And in VPN, we have gateway to gateway only. And you can be used to connect to any IPsec compliant gateway. And in firewalls, you have to set up the rules, apply rules to the tags, and you have to apply tags to the hosts. And one more, there is a cloud DNS where you can publish and maintain DNS, domain name system. And it records by using same infrastructure Google uses. You can use Google Cloud Console, a CLI or REST APIs to work with manager zones and DNS records. Cloud VPN enables you to connect your existing network to your VPC network through IP section connection. You can also use VPN to connect two cloud VPN gateways to each other. For cloud load balancer, it is a HTTP and SSL internal and network. And in DNS we already discussed, and CDN it is like activate through our load balancers, and it uses HTTP headers to determine cacheability. HTTPS load balance enables you to distribute traffic across regions. So you can ensure that requests are routed to closest region, or in the event of failure or other capacity limitations, to a healthy instance in the next closest region. You can also use it to distribute traffic based on content type. If you want to set up your services to deliver static content such as images and CSS from one server and dynamic content such as PHP pages from different server, the load balancer can direct each request to server that provides each content type. Operation services. And in operation services, we have Stackdriver logging, Stackdriver monitoring, Stackdriver trace. In Stackdriver logging, we can cross cloud logging. We have GCP, AWS, and on-premise. And in Stackdriver monitoring, we have cross-cloud monitoring like GCP and AWS. It supports alerting. And in Stackdriver trace, we can automatically create app engines and load balancers. And it enables through an SDK. And we have links to logs. Machine learning services. And in machine learning services, we have Vision API, Natural Language API, Speech API, and Translation API. Vision API, we have face detection, loading detection, and logo detection, and OCR. And in Natural Language API, we have syntax analysis, entity recognition, sentiment analysis, and multi-language. Speech API. Speech API is like an automatic speech recognition. It supports streaming and it supports up to 80 languages. And in Translation API, it supports the language detection and it translates the language to any language in the globe. It is a whole document type. Thank you.